So we here at Tianma with a 5.49-inch flexible AMOLED. And this is the phone maybe of the future that's able to flex. Nice. That's cool. So this is 1080p plastic.
Yeah.
It's plastic, it's not the glass.
Yes, it's not glass. It's the flexible AMOLED, and originally developed by Tianma, and it's kind of it's like future technology and the future display.
So here's some information about it.
Yeah.
Full HD AMOLED, and with all these layers, and actually made simpler and thinner and lighter. And what's over here? This is a...
It's a 5.5 Full HD AMOLED display. It's for the mass production.
Mass production,
It's
1080p.
Yeah.
But this is not plastic, no?
Yeah, this is rigid on glass.
And here also,
Yeah.
as a higher resolution AMOLED, 5.2 inch.
Yeah,
All right, this is not plastic also, right?
yeah, this is rigid.
All right. So let's check it out here. Hello. So we're here at the Tianma booth. So who are you?
I'm Bob Dunhouse. I'm the Senior Manager for Apps Engineering for North America.
So let's do a booth tour here at the SID Display Week.
Sure.
You have lots of cool displays. If I go around here, this is Force Touch. And this is an 8K 10.4 inch. Crazy high resolution, right? The highest pixel density in the market, maybe. And here's another one. This is just retina display.
Yeah, so this is called touch embedded. So this is actually an embedded touch sensor as opposed to an add-on.
So is it in-cell, something like that?
Yeah, it's actually, that's what we call embedded in-cell.
In-cell. And what does this one do here?
This is actually what we call our Tech Plus, which is the acronym stands for touch embedded display. And it does really a few things. So they embedded the touch, and they added a force sensor as well.
So this
he's
force.
demonstrating it here.
Force Touch, 5.5 inch, Full HD Force Touch.
Yeah, it's an in-cell force touch. All the sensors, including the touch panel and the force sensor, are embedded inside the panel. So our panel can do everything.
So this is very special. You're nominated for Best in Show.
Yeah.
Are you gonna win? Maybe.
Yeah, maybe.
Maybe with this. All right, let's walk around over here. So you're doing stuff with the R&D prototypes for VR. So you have the displays in there that are super high resolution. And here also, yeah.
You might be interested in this. This is a large format see-through panel, a transparent panel. It's 27 inch.
So this could be for vending machines or...
Well, you're actually seeing this now on refrigerator applications.
Nice.
Yeah.
So you can click, and if the fridge is empty, you can get a taste for what you could get, and you click and order it.
That's right. Good.
Right.
Possible.
And right here, this is also very high resolution VR display in there.
And then on the wall, this is our industrial section. So this covers a lot of the industrial apps for could be white goods, could be transportation, could be medical applications, many applications.
So this is super wide. This is some special resolutions, 888 x 408.
That's right.
Special ones.
Mm-hmm.
And they're designed to be more like sturdy.
For industrial applications, they have higher temperature ranges, they have higher shock and vibe specifications, higher clearing temperature ratings. This is medical field, and as you can see, many of these displays are wide format, becomes a trend in medical. This is our new 30-inch, 6 meg color panel. And this was developed for medical space that wanted to have two industry standard, what you see here is medical imaging, x-ray imaging, but they wanted to have it side by side. Typically it was done with two separate monitors, The problem is maintaining color balance between two separate monitors. By combining it on a separate monitor, that means the grayscale differentiation between the two remains equal.
And that could like give false.
False diagnostics.
That was an issue, just because the display is different, or display is slightly different.
Each display could be slightly different from a color temperature standpoint. The grayscale could look a little bit
different.
This is 10-bit. This is 10-bit, yeah. Very, very high color resolution.
That means millions of billions of colors?
Yes, millions of colors.
Millions of colors, and the other ones are much less.
Less, that's right.
Right.
And then we have a 21.3 inch. This is a 5 megapixel. 2560 by 2048 resolution. Very dynamic also. It's running 1,000 nits. It's 1,300 to 1 contrast ratio, so you need very, very dynamic contrast when you're doing medical imaging.
All right. And over here you're showing a PCAP, that's capacitive.
Yeah, it's
technology.
Projective capacitive technology. And you can see here, this is a multi-touch, 10-point touch. Can be up to 6 individual tracking points. This is a 15-inch. This sensor was developed in China. Here we have various other capabilities here. Again, this is touch panel. This is really just demonstrating the difference between direct bond and air gap bond.
What's the difference?
One uses an optically coupled bonding material. The other one is just an air gap between the actual add-on PCAP sensor and the display itself.
So that means less reflections and high quality. What does it mean? Better touch?
With the direct bond, when it's optically coupled, you get less internal reflection. It's better for outdoor viewing, and there are some mechanical considerations as well because it's a little more mechanically stable.
And a whole bunch more. So
Yeah,
these
this-
go in kind of like smartphones. Some of these.
Could. The round display you're seeing here has an obvious application for thermostats. It is true round. It's not a flat tire design, which up to now a lot of the semi-round displays have always used a flat tire on the bottom. This is truly round.
So now the tray is going to get cooler a little bit. I just loaded temperature. And what is this?
Yeah, these are more touch panels. Looks like one that we need to boot back up again. But what you see here is all PCAP technology. The difference is this one actually uses a 10 millimeter cover glass, which has been very difficult to do to this point because getting the projected capacitive field to extend beyond that very, very thick cover glass has been difficult. But now we're able to do that with this product. This is using an air gap, a little bit thinner glass, but it has an air gap between the cover glass and PCAP sensor to the panel. Everything that you're seeing down here is in larger sizes. It shows our ability to do many different add-ons as far as cover glass, black surrounds. We do AG etch, AR coatings, AR films, AG films, anti-fingerprint coatings, custom corners, cutouts, many different things that we can do in cover glass right now. These are designed and integrated in Japan directly at the factory. So the big positive there is that it's not done by a third party. Therefore, you get the factory warranty.
Where is Tianma based?
Tianma is based in a couple different places. It's based out of China and also in Japan.
Japan also.
Mm-hmm. That's right.
This display looks like a special one.
These are kind of wide, thin displays that you've seen in the recent Apple MacBooks.
Oh.
So we're kind of looking at that type of application. You're in the research and development technology area right now, so these are not products at this point, but could be.
All right. And here you have.
Yeah, this is a demonstration of the various outdoor viewable technologies. So the original transflective, which is a reflective-based technology, and this is showing front lighting, and you can turn the front lighting off. But this is turning on and off the backlight. So you see there's not a whole lot of difference here using a very bright
Yeah.
front lighting. So it's pretty reflective.
You sell this?
This one, we're making a transflective version of this. This is the new high reflectivity technology. And again, you're in the research and development section. So this is just improving the reflection ratio on the TFT level. And then this is a standard transmissive panel in the same size. And you can see here by turning the backlight off, very difficult to see even with the high brighting, the high bright light here.
Here's backlight off.
Yeah, that's backlight off, backlight on.
That means 50 times longer battery life if this was in a phone.
Yes, exactly.
But are you shipping any phones like this?
We don't ship
Oh, you're
telephones.
shipping the screens to somebody who's going to ship the phones.
We do make the transflective. I don't know if they're being used in the phones
They
specifically.
should, right? Because this is going to bring you weeks of battery life.
Actually, the trend is going to be in OLED, which was what you were looking at before.
The power is still high, no?
No,
It can be lower,
very low.
especially when it's black background.
OLED, very low. Yeah.
Right, but I think this is pretty cool.
So it just shows you that, you know, with standard transmissive panel, you can get more, you know, definitely brighter images, more colorful images. But really the key here is that this new high reflectivity represents colors better.
How about
than
when you put the backlight on? Can it be as good as a normal full LCD?
No.
It can't. There's
No.
some kind of missing stuff.
It's actually, if you look down on the TFT layer, it has a reflective layer, and within that reflective layer, there are certain openings that allow the light to pass through. It's aperture openings, and to get the high reflection ratio, you have to have a lot of reflective material, which means you have less openings to allow light pass through. So therefore, the peak luminance can never be what it is for a fully transmissive panel.
You can't make it as saturated as many colors and as many contrast and all that stuff.
Not compared to a fully transmissive panel. No.
Right.
You want to go in?
Walk around.
Yeah.
This is no bezel.
So again, we're still in the research and development area, so you have to understand that these are the things that we're looking at. But the key here is the trend in smartphones is to make the entire front surface of the smartphone a full display.
There's no bezel all around.
Yes, well, very, very minimal
At the bottom.
border here. So we're down to 1.8 millimeters.
Just at the bottom only.
Yeah, well, yeah, and only half a millimeter on the sides. So,
And at the top also half a millimeter maybe.
it's probably
Yeah.
a little bit more than that, but not much.
So that could be the size of the phone. Just
Yes.
all around,
Yes.
just no bezel.
That's right. That's right.
And here also.
And that one also. That's correct.
And we're looking at these kinds of resolutions. Does it only work with LTPS?
Probably in this size. I mean, that's just defining the background, but probably in this size, LTPS makes sense.
5.46 Full HD, WQHD.
That's right. This is an interesting demo. This is showing that we can do custom shapes as well. In this particular case, we have a cutout in the center, and both of these panels have integrated touch panel as well.
How's this possible? Square ring TED. What's the TED?
It's touch embedded. So
Touch embedded?
that's the actual touch sensor that's embedded in the display itself.
And that's LCD?
It is LCD. That's correct.
But it's just R&D. What could be the use? There could be a clock in here.
Could be a clock. Could be. You could put a display within a display and control them independently.
Oh.
Or you could put a clock face in there.
I think it's awesome.
This just shows a high reflection ratio.
Freeform transflective.
Really, this is just demonstrating that we can do complex shapes. You see here, it's not a rectangular display.
All right.
This moves back into the large screen medical space. This panel is in R&D, but it is the 30-inch medical display we looked at earlier, except this one has a PCAP integrated sensor to it.
It's touch.
That's correct. That's correct.
What does this one do?
This is an OLED display. It's 4.2 inch
480.
What makes this one a little bit more special is it's coming out of our Japanese factory. It is designed for the automotive area. So higher temperature spec. This one has a peak luminance of 650 nits. So it's very, very bright for an OLED display.
Whoa. So this can be in the car where you have to see it, even if it's very sunny.
Yes.
And you just see the screen.
That was for the demand for the 650 nits.
Nice.
That's correct. This is a curved display. But not only is it a curved display, but the PCAP sensor itself was actually integrated into the curve. This is an add-on PCAP sensor.
All right.
So in essence, they use a very, very thin glass substrate that they bend to get the curve.
Nice.
This is a tactile feedback presentation. This normally with some sort of haptic feedback,
it's vibrating.
or tactile feedback. Yes,
It's haptics.
so it is haptics. So you won't be able to feel a texture if you don't move your finger. If you move your finger across the turtle, you'll get a haptic feedback.
It's not like a normal haptic. It's like it feels like to be under the finger.
Yes.
So it's like
So you
following
see
the
it's-
finger.
It's following the turtle, right? So it's image specific.
Also, but is it the whole screen that's vibrating, or just the part where I'm touching?
Actually, that's what makes it different. It's not standard haptic. Normally, haptics use some sort of mechanical transducer. This has no moving parts at all.
No moving parts. But am I getting an electric shock or something?
It's an electrostatic sensation. So it's done by intersecting sine waves.
Whoa. So there it is. Some information about that.
Yeah, and actually the circuitry was integrated with the PCAP sensor itself to give you this electrostatic feedback that you perceive as a texture. And we can create different textures as well.
It's very interesting.
So-
Very special.
Yeah.
All right. Over there, there's a. If I jump in here, that's right. Are we looking at a hologram?
So to step back a little bit, this is what we call a free floating image. And if you look at it, the fireball that's here, this is a combination of many different technologies. It uses our 19.5-inch display mounted horizontally.
Inside there somehow.
You can't see it. You won't be able to see it.
I'm touching the fire if I get too close.
Yeah, that's right. So you can see here.
Whoa.
Yeah, you have to move your hand in here. There's an optical sensor in the back. So this is a combination of...
And it's hot.
Yes. So
Is that on purpose?
Well, yes, it is, actually. So we have our 19.5-inch panel on the bottom. It's an auto-stereoscopic 3D display. It projects up through what we call this aerial lens. This aerial lens creates the floating image that you see here. We've also incorporated in that some thermal transmitters. The glass itself, the lens itself was created by Matsunami Glass. The thermal transmitters were created by a university in Japan. And then we use a Kinect camera to give you the motion of when the actual fireball should expand. And then we have some audio that's running as well to give you some audio effects.
It's an interactive hologram.
Yes.
All right. Also, best in show nominee.
Right.
Hologram. Because if you move from one side to the other, you
It's
see
moving.
right
Yeah.
away. But if you come from this side or the other,
Yeah.
this is
Well, it's all dependent upon the lens, first of all, and then second of all, it's a 2D auto-stereoscopic display, which means you only have certain fields of vision.
All right. Cool. Thanks. Let's walk around over here. There's a whole bunch more. Sorry. More professional displays.
Yes, more professional displays. And this display is really quite interesting because there's some thought about making a rear view mirror in an automobile an actual display. So you could have you could switch between rear view cameras or some sort of informational display.
All right.
And again, these are all industrial, professional displays, we call them.
And here's some more.
And yeah, this moves into the automotive space. So, of course, liquid crystal displays in automotive applications are becoming more and more prevalent out there. This is really taking, we have the same 12.3-inch panel that we're using along this entire space here, but with different technologies. So this one is using local area dimming. This is conventional panel. This is local area dimming. This actually dims on a regional area depending upon the video content. So
It cannot be by the pixel, it's by the area.
yeah, there's small areas that are defined. It's a direct backlit plane, and it's controlled based on that. This kind of local area dimming has been used in LCD televisions for quite some time, but not really down in the industrial level.
So that means you would get better blacks, or
You get better blacks, yeah, more dynamics. You can actually see here. Lower power consumption would be another advantage. Sure. This is what they call optical alignment. So part of the liquid crystal display manufacturing processes is to set the alignment layers at the TFT cell level. And to do that, normally it's done with a cloth wheel that rubs over the top of the alignment layers to set the alignment of the liquid crystal. In this particular case, it's completely touchless. It's done with a UV exposure. And the major advantage to that is uniformity. So you get when you look at the blacks, it'll be extremely uniform. It doesn't cause variations in gray. Also better contrast ratio. And potentially less image retention because it leaves less ionic contaminants in the TFT cell.
so it's called. This is 1920 by 720, all of them.
They're all same display, but different technologies. So 12 this is 12.3, same one, but this is using an overdrive method. So it's overdriving at the TFT level to improve response time.
All right, faster response.
Yeah, so that's also been used in liquid crystal displays in televisions for quite so many years, but now it's filtering down to the industrial level. This is just showing that we can take the same panel, we can make it in a curve format.
All right, awesome. And then the last part is over there.
It's something that was very popular,
More stuff.
something they have a lot of interest in.
Around
So
here.
that's why we're showing them here.
What is in here?
So this is a heads-up display.
This here
You have to back off there. You can see
Yeah.
The thing that's unique about
heads-up
it is
displays for automotive use.
Okay.
it's able to achieve only 4 millimeter thickness.
A fit. What makes this one special as opposed to last year is this is a color display. So last year we had a monochrome display, and we moved to a color display.
And here is some HD
This is
AMOLED.
again another
Automotive,
OLED display, 5.46 inch.
Let's go over there.
Display that is very thin. So this allowed us to develop design rules.
One second.
so
And
that we
there's
can
This is a 14
displays to customers. We figured out what the
TFT
mechanical
display, of
structure
course,
would be,
but this also has a touch panel embedded in it as well.
for automotive customers to achieve the thinness
This could be for a car.
required because
Could be.
Getting
See,
people asking for that for
Tesla would be a prime example of a center display.
yeah. So
They use a larger one than this, but
yes, the
could be applicable.
And there's just a couple more here. This one.
they want to have a display sticking out of
HD,
the
and over there,
and they of course
design
don't want
slim with a
Very
CPT,
thin,
it to be very thin.
8-inch.
Yes.
All right,
Also with a touch panel integrated in it as well.
So here at the SID Display Week, you're really providing the blockbuster, the latest, all the latest R&D products. You're showing off a lot of cool stuff and things like this.
Yeah, I think the flexible display is a very hot topic these days. People want to be able to fold and roll. So I think OLED on flexible substrate is really important.
And this is manufactured in China, that one.
It is.
China, but Japan also. Some of the other things.
Yeah. Japan does some OLED as well, but primarily we have one fab that's online right now. This is a mass-produced OLED part. All of this is primarily aimed at smartphone application, which is exactly what we're showing here. So all of our production volume is being used for smartphone right now. This is an upcoming panel that will be out next year.
All right.